Ran out of battery at the exact same time, so we're going to do this the old-fashioned way. Chapter 16, homework. We've got question 1 here. So we're going to start out, we have a, I should pull up the question so I can read it off exactly. Alright, motion of the 2.5 kilogram rod AB is guided by two small wheels which roll freely in horizontal slots. If a force P of magnitude 8 newtons is applied at B, determine A, the acceleration of the rod, B, the reactions at A and B. So we've got our free body diagram here, which is awesome because it's free, obviously. We've got our position, our point A, point B, our radius here, and then our force P up here. And also we should identify anything the problem gave us. We have our translation, our mass is 2.5 kilograms. Our force P is 8 newtons at B, and we'll write down our equation. Sum of forces is equal to mass times acceleration. And we're going to try and find the acceleration of the rod, and we're going to find the reaction at A and the reaction at B, which I ended up calling NA and B because they were basically just the normal forces, but anyway. So we went ahead and drew our other free body diagram just to kind of identify where all the forces are coming from. We have our normal force at B and our force of P, our mass times acceleration. We have our the weight of the weight equals the mass times gravity, which is the weight's also our force. And then we have our, I guess technically we don't have our force at P, but our force of P is technically acting on A because it's being pushed on B, it's coming through the rod and pushing on A there. And then we also have our normal force at A. So we've got our sum of forces in the y direction is equal to mass times acceleration. That's 2.5 times 0 because we don't have any acceleration up or down. Our normal force of B plus normal force of A equals negative weight. Let's see here. Our normal force at B plus our normal force at A minus our weight equals that mass times acceleration, which is 0, and so we get our normal force at B plus our normal force at A equals negative weight equals negative mass times gravity, and ends up becoming normal force at B plus normal force at A equals 24.5. Then when we do our moments, we have the moment of, so we have the sum of moments. So we have our moment of, we're going to do our moments centralized at A, or around A, about the sum of the moments about point A. There we go. We have, and then equals our 0.3, which is our radius, because the distance between point A and point B just laterally here is 0.3, the radius of times the force, normal force at B, minus the minus our weight times the length, and I've just denoted length as L right here, and I'll get to that in a second, equals our inertia times angular acceleration. And let's see here, acceleration, sorry, it's hard to see upside down, plus mass times acceleration times distance. So to get to our L, went ahead and started a new little free body diagram down here, and I can have as many as I want because they're free. Our 45, so I needed to find the L distance between the center of gravity right here of the rod, and A. So the distance, and this is when we're looking at it, and I'm just going to have it in the x direction for here just to make the math simple. So we have 45 degrees there. L becomes sine 45 equals L over 0.3, and L equals 0.2121 meters. Yeah, it's meters, not millimeters. So we went ahead and plugged that in for here. So we have our 0.3 normal force at B minus our force of our force, which is 24.5 newtons, and that is our mass times the acceleration due to gravity, or mg, times our length L, 0.2121 meters, equals the inertia times angular acceleration. And seeing as it is just a translation, it is not any rotations or anything, our angular acceleration can be 0, plus our mass times acceleration times distance, and the and this point, let's see. Yeah, so our masses are 2.5 kilograms that we were given in the very top of the equation. Our mass, our acceleration is at 3.2 meters per second, and our distance, our perpendicular distance, is going to be the distance between here, between the here and here, which is just our our distance between right here and right here, which is 0.3 minus 0.2121. And that we were able to solve for our NB, which is equal to 19.665 newtons. And then if we plug NB up into our equation of NB plus NA equals 0, that gives us our NA of 4.835. And I also forgot to mention that up here, to find the acceleration, that was really simple. We just did our sum of forces equals mass times acceleration. And right here we just have the force of P pushing in the right direction, to the right, and then our mass, which is 2.5 kilograms, times acceleration, which acceleration equals 3.2 meters per second squared.